Okay, let's get started with 3.2, graphs of functions. So we're going to introduce four new things here. So even and odd of a function, and that's actually going to be similar because you've done symmetry before. We'll see that. We'll talk about when functions are increasing, decreasing, and constant. And then two new formulas, average rate of change and the difference quotient. We are not going to touch on piecewise functions in this video. We will come back to that for a project later on. Okay, so here's the two formulas I talked about, the difference quotient and the average rate of change. So go ahead and get those two down, and off we go. All right, before we get started, I do want to touch on some common functions that you're going to see a lot. All right, so you may want to pause the video and just get these down. So just standard functions, y equals just your regular linear function, 5x plus 3, will be a graph that looks something like that, a straight line going diagonally, okay? Y equals something like 5 will be horizontal. Okay, y equals x will be a diagonal line with a slope of 1 through the origin. Y equals x squared, that is a parabola. Y equals x cubed, that is this shape here. This is the square root of x, the cube root of x, the absolute value of x, and 1 over x looks like this. It never touches either of the axes. Okay, you do not need to know the rest of the information, just the general shape of what they look like. Okay, let's talk even, odd, or neither. So an even function, even, has y-axis symmetry. An odd function has origin symmetry. Okay. Now, we're not going to have x-axis, no x-axis, because if you did, so here's a graph, there's a function that has x-axis symmetry. There's the x-axis. This would not pass the vertical line test, so it is not a function. No x-axis symmetry because not a function. Okay, so let's look at this. So how do we find out if something's even or odd? Remember that to find y-axis symmetry, we plugged in a negative x. We're going to do the same thing here. Plug in negative x and see what happens. In this case, negative x squared is just the same as x squared minus 3. That's exactly what you started with. So if you plug in negative x and get right back to where you started, you have an even function. All right, so if you plug in negative x for this one, get negative x to the 5th plus negative x cubed. So a negative times itself 5 times is a negative, so we would get negative x to the 5th. And a negative times a negative times a negative would be a minus x cubed. All right, this is the opposite of what we started with. So it's not even, but if we divide this by negative 1, then we get right back where we started. And so if we have a function where we plug in negative x, divide by negative 1, and end up right back where we started, that is odd. So let's test C. If we plugged in negative x, we would get negative x squared minus negative x, which is x squared, plus x. Not what we started with. We see a minus there, but a plus here. And if we divide by negative 1, we get negative x squared minus x. So now we match up the minus x, but this is positive x squared and this is negative x squared. So this would be neither. All right, your turn. Give it a shot. All right, hopefully you got even for the first one, because if you plugged in negative x, the absolute value, that just back into a regular old absolute x, which is what we started with. And the second one, hopefully you got neither, because if you plug in negative x cubed, you end up with negative x cubed minus 1. Not what we started with here. We divide by negative 1, we get x cubed plus 1, which is not what we started with there. So this is a neither. Okay, let's talk increasing and decreasing functions. So to talk increasing and decreasing functions, we're going to think about ourselves as a hiker walking along the function. And we're going to figure out where we're going downhill, where we're going uphill, and where we're walking on flat ground. Okay? Now, for all of these, you want to report the x values. All right, so I want to know what x values am I going downhill. So for this one, I'm going downhill from -1 to -2, the x values. I'm going uphill from -2 here to an x value of 0. Okay, so when we talk about increasing and decreasing, even though we're talking about up and down, we never write down the y value. So let's take an example. What's our domain and range of this function? So the domain would be -5 and touching it. And we're going to the right forever, comma, infinity. The range, what's the lowest point we see? I see a lowest point of 0, which we're touching. And this is going up forever because of the arrow here. So 0, comma, infinity. All right, so let's find the intervals. So we're going to start far left. We're going to think about ourselves as a hiker. So we are decreasing from -5, the first x value, all the way up to -2. We're going downhill, downhill, downhill until we hit this point. Now notice that I put parentheses around both of them because when I'm standing here at -5, so if I did bracket -5, if I'm standing right there, I haven't started walking downhill yet. I actually have to step off of -5 to walk downhill. So we're going to use parentheses for all of these. All right, we are constant from an x value of -2 all the way up to an x value of 0. We then continue walking downhill from 0 all the way up until 2. Remember, we're just using the x values. And then we start walking uphill again from 2. And we keep walking uphill forever, so to infinity. All right, let's try average rate of change. So average rate of change is just a fancy word for slope. Remember that slope is y2 minus y1 over x2 minus x1. Or remember that it doesn't matter if you switch them. It could be y1 minus y2 over x1 minus x2. All right, so average rate of change, we're just finding the slope. So let's find the average rate of change for this function from part A from this x to this x. So we're going to say f of the first x minus f of the second x over the first x minus the second x. If we plug -1 into this, this would be -1 to the fourth minus 0 to the fourth divided by -1 minus 0 is just -1. So this would be -1 to the fourth is 1 minus 0 over -1. And so that is -1. That's your average rate of change. Let's try the next one. So we're going to plug it in. So we're going to say 0 to the fourth minus 0, minus the second number, minus 1 to the fourth over the first x minus the second x. So that would be 0 minus 1 over 0 minus 1. That equals 1. That's your average rate of change. Let's try it again. 1 to the fourth minus 2 to the fourth over 1 minus 2, sorry. So that's going to be 1 minus 16 or 1 minus 2, which is -15 over -1. So an average rate of change of 15. Your turn. All right, we would get -2 squared minus 0 squared over -2 minus 0, which is 4 minus 0 over -2 minus 0. 4 over -2 is -2. And then we would have 0 squared minus 2 squared over 0 minus 2. So this is 0 minus 4 over 0 minus 2, or -4 over -2, which is +2. All right, difference quotient. So the difference quotient is what's the function if you plug in x plus h minus the original function, and then take the whole thing and divide by h. So this is a function you're going to use in calculus. We're going to introduce it here in Algebra 2, and then we'll see if you get to it at the very end of pre-calculus next year, if not senior year in calculus. So here we go. The formula f of x plus h minus f of x all over h. So for this function, f of x plus h would be 2x plus h squared plus 1. So let's simplify that. That's 2x squared plus 2xh squared. Remember, you have to square it, plus 1, which is 2x squared plus 4xh plus h squared, 2h squared plus 1. Okay, then, so that's this first part. then we're going to subtract the original function. So we're going to say minus 2x squared and plus 1. So those cancel and those cancel. If you're doing this right, every term without an h should cancel. So what do we have left? We have 4xh plus 2h squared. And we have forgotten about dividing by h. We're going to do that at the end. So divide everything by h. You get 4x, 2h. And that is your difference quotient. Okay, your turn. See if you can give it a shot. So f of x plus h is negative x plus h squared plus 2. That turns into negative x squared plus 2xh plus h squared plus 2, which is negative x squared minus 2xh minus h squared plus 2. And then we're going to subtract the original one. The original one is negative x squared plus 2. Those and those cancel. We're left with negative 2xh minus h squared. Divide the whole thing by h, and you get negative 2x minus h. Okay, so I said we're going to do piecewise functions next time, so that will do it for this video.